Hey guys, this is Mrs. Harbin, and we are going to continue our Roots and Radicals unit by looking at the Pythagorean Theorem. The Pythagorean Theorem is probably one of the most famous mathematical theorems. It's used in a lot of different disciplines. It's used in algebra, it's used in geometry, it's used in trigonometry and calculus. So it's really important that you guys have a good understanding of the Pythagorean Theorem. The Pythagorean Theorem was published or written about by a guy named Pythagoras. It's possible that other people used it before Pythagoras, but because he was the one who published it and kind of made it famous, the theorem is named after him. Now, before we delve into the Pythagorean Theorem, let's take a look at a couple of hopefully easier problems that you guys know how to solve that will get us kind of on the right track to solve problems using this theorem. So let's take a look at x squared equals 16. We know that x squared equals 16. If x represents a length, then we know that we want to use the positive root. We know that in order to solve for x, we need to undo the square term. And to undo a square term, we've got to take the square root. So we're going to take the square root of both sides. When we do that, we get x equals plus or minus 4, because positive 4 times positive 4, 4 squared equals 16. But negative 4 times negative 4, which is negative 4 squared, also equals 16. So the square root of 16 can either be plus or minus 4. That's what this little symbol means, plus or minus. But if we're measuring a length, then we don't want the negative 4. We just want a positive number. So our length would be x equals 4, positive 4. Today, your objective is that you will use the Pythagorean theorem to find the length of the third side of triangles. Let's go over some definitions. So just a quick review back to geometry. Don't forget that a right angle is an angle whose measure is 90 degrees. This would form the shape of an L, although this is not a perfect 90 degrees. And you'll see this notated in triangles with a little box in the corner to tell you that that is a right angle. If you don't see this, and you're dealing with triangles and you don't see that symbol, it just kind of looks like a right angle, don't just assume. It could be off by just a little bit. So when you are dealing with any kind of right triangle or right angle, it's going to be marked if it's a 90-degree angle. So look for that little mark. A right triangle is a triangle that has a right angle. So right triangles have one right angle that will be marked and look kind of like this. This is a terrible triangle. I am freehanding it. Now, as far as the names of the sides or parts of a right triangle, the two sides that form the right angle, we call those legs. So this is a leg and this is a leg. Together they form the right angle. The side that does not form the right angle, that's directly across from the right angle, is called the hypotenuse. And I'm not going to write that out right now. I'm just going to write HYP. That is the hypotenuse, or the long side that's across from the right angle. A theorem is a statement that has been proven to be always true. And the Pythagorean theorem has been proven over and over and over and over and over again to always be true. We know that equations and theorems basically just describe or define patterns that we recognize that God has created. And so there are over 200 different proofs that have proven this theorem to be true. The Pythagorean theorem says, the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. Now that is a whole lot of words. And so let's put that in simpler terms here. So if we take the lengths of the legs, our two legs, and we square them, so we take leg 1 and leg 2, so leg 1 squared and leg 2 squared. We'll put L1 for leg 1 and L2 for leg 2. So we square the lengths of the legs and we add them. That's what sum means. So the sum of the squares of the legs, what that is equal to, it's equal to the length of the hypotenuse squared. We could write that as hypotenuse squared. So leg 1 squared plus leg 2 squared equals hypotenuse squared. Now, most of the time you will not see that written as leg 1 squared plus leg 2 squared equals hypotenuse squared. You will see it written with this notation. A squared plus B squared equals C squared. And if you look at this, you can see that this is a leg and this is a leg. So our A and our B are legs because they form the right angle. And across from the right angles are hypotenuse, represented with C here. Okay, so you can write it either way. A squared plus B squared equals C squared, or if you would rather write leg 1 squared plus leg 2 squared equals hypotenuse squared. You can write it that way as well. But what you need to know is that the 2 legs squared, if you add them together, you'll get the hypotenuse squared as well. And we did take a look at some proofs of this in class, and I'll try to share some other videos on the playlist so you can see that proof being proven in action. Well, we can use this theorem to help us solve missing sides and eventually missing angles and right triangles. So let's say we're given a right triangle and the legs are 12 and B. We don't know one of the legs. The other leg is unknown, but we do know the hypotenuse. It's C. The first thing that we're going to do is write our Pythagorean theorem. We're then going to substitute in what we know. And we know that A is 12, B remains unknown, so it's going to stay here. And we know that our C is 15. So we're going to plug in each of those known quantities, and then we're going to solve for our unknown leg, or solve for B. 12 squared is 144, and 15 squared is 225. Don't forget to know your perfect squares 1 through 15. If you have not learned those yet, learn those. We'll then subtract 144 from both sides, and we get B squared equals 81. To get B by itself, we need to undo the square, and we do that by taking the square root. Square root of B squared is plus or minus 9. But because we're dealing with distance and measuring the length of a leg, we're only going to use the positive root. So we're going to say that B equals 9. Since B is the length, use a positive solution. B equals 9. All right, let's solve x squared equals c. To solve an equation of the form x squared equals c, you just take the square root of both sides of the equation. Okay, you just saw us do that. With x squared equals 81, we took the square root of both sides. Because to undo the x squared, we've got to take the square root, and whatever we do to one side, we have to do to the other. We'll always get a plus or minus value, and when we're talking about distance, we'll only use the positive root. Let's solve another triangle here. The legs are a equals 10 and b equals 20. The hypotenuse is unknown, represented with c. First things first, let's write the Pythagorean theorem. A squared plus b squared equals c squared. We're then going to plug in what we know. So our a is 10, our b is 20, and our c remains unknown. We know that 10 squared is 100 and 20 squared is 400. C squared is still unknown. We add our like terms, 100 plus 400, and we get c squared equals 500. To get the c by itself, we're going to take the square root of both sides. So we get c equals plus or minus the square root of 500. We can simplify that by using perfect squares. 500 is just 100 times 5, which is the same thing as the square root of 100 times the square root of 5, and the square root of 100 is 10. So we get 10 times the square root of 5, plus or minus 10 times the square root of 5. Again, we are dealing with distance. We're dealing with an actual measurement of a side of a triangle, so we want to leave that as, click too soon there, 10 times the square root of 5. Unless you're asked to put it into a decimal form, you do want to leave it in radical form. Decimals, we would have to round up, and we would lose some of our precision. 10 square root of 5, we don't have to round anything, so it is more precise answer. So unless you're told to put it in decimal form, leave it in root or radical form. We can also use a Pythagorean theorem then to find the distance between any 2 points. And this is some of the usefulness of the Pythagorean theorem, because you can make a right triangle out of a lot of different things, out of a lot of different points. And so we can use it to help us find the distance between 2 points. Let's say we want to find the distance between these 2 points in the Cartesian plane. We have 5, 4, which means we've gone to the right 5 and up 4 right here, and negative 3, 1, which means we've gone to the left negative 3 and up 1. And we want to find the distance between those points. So the first thing we want to do is make a right triangle. And if we draw a line here, and draw a line here to connect. This is not going to be a very straight line here. You can see that we have formed a right angle or a right triangle. Once we've done that, we want to determine the length of the legs. Now, it's easy on a Cartesian plane. If the box is already marked for you, you can just count the boxes. 1, 2, 3, that's 3 units. And 1, 2, 3, 4, 5, 6, 7, 8, that's 8 units. Okay, you could also take your 4 minus your 1 and get 3 units, and 5 minus negative 3, or negative 3 minus 5, and that gives us 8 units. So you can subtract your y values and subtract your x values if the boxes aren't there for you. Now we know the length of the legs, we can use the Pythagorean theorem to find the length of the hypotenuse. A squared plus b squared equals c squared, or 8 squared plus 3 squared equals c squared. Solve that on your own. Come back and check your work to see if you got it right. All right, we have 64 plus 9 equals c squared. When we combine our number terms, we get c squared equals 73. We're going to take the square root there. C squared equals plus or minus the square root of 73. And when we take the square root of 73, it doesn't simplify any in root form, so we would just have positive square root of 73. If we're asked to put it in decimal form, then it would be approximately 8.5 units rounded to the 10th place. Now, the distance formula is just another variation of the Pythagorean formula, Pythagorean theorem. It's going to look a little bit different, but it represents the same information. So it's just another way to find the distance if you don't feel like drawing a triangle. So we can find the distance between any 2 points on the Cartesian coordinate plane. This is the Cartesian plane using the x and y axis named after René Descartes. And it's called the coordinate plane because we use an x and y coordinate to represent every point here. Right? If you remember, the Pythagorean theorem is just a squared plus b squared equals c squared. If we wanted to write that differently, if we take the square root of c squared, if we just want to know c, we'd take the square root of c squared, and we would have to take the square root of this. So we would get c equals the square root of a squared and b squared. Well, remember that a squared and b squared just represent our legs. What if we're not given a number, though? What if we're given 2 different points? Well, you can see that we can write that as, our a side is x minus x. So a squared would just be x minus x squared. And our b side is just y minus y. So we would substitute y minus y squared. And what we have here is what's called the distance formula. We took the Pythagorean theorem, we just wrote things in a little different order, and we come up with the distance formula, which looks like this. X squared minus x, x minus x, these sub numbers here just represent which x. So x2 minus x1, just showing you that you're using 2 different x points here, squared, plus y2 minus y1 squared equals d. If you remember, this was a squared plus b squared, and we took the square root of that to equal our c, which is going to be our distance. So this is just a derivative of the Pythagorean theorem. If you don't feel like drawing a triangle, though, you can use this to help find your distance. So let's find the distance between these points. Now we could pull out a graph, we could graph these points and make a triangle, or we can just plug it into this formula. So our 2 x values are 2 and 5, so we're going to plug those in here. And our 2 y values are 1 and 1, so we will plug those in here. So we get 5 minus 2 squared and 1 minus 1 squared. Well, 5 minus 2 is just 3 squared, and 1 minus 1 is 0 squared. And 3 squared plus 0 squared is just 9. Don't forget, we're taking the square root of this whole thing because we want to find that distance. So the square root of 9 is 3. It's plus or minus 3, but we're just going to use the positive 3 since we're finding distance. All right, find the distance between these 2 points. Pause the video, try this on your own, and then come back and check your work. Okay, let's see how you did. Here's our 2x values that we want to plug in. And then here are our 2 y values that we're going to plug into this equation. And we have 6 minus -2. Be careful when you're plugging in negative numbers that you protect that negative sign by using parentheses. And then we have -5 minus -9. Again, protect those negative signs there by using parentheses. When we simplify that, we get 6 plus 2 squared, which is just 8 squared here, and -5 plus 9 squared, which is where we get our 4 squared here. 64 plus 16. And then we have the square root of 80 because we've added the 64